Planet Earth, a world of incredible diversity. From towering mountain ranges to vast flat plains, our planet's surface is anything but uniform. Geographers use a concept called relative relief to describe these variations in elevation. Relative relief tells us how much the land rises and falls within a specific area. It's about the difference between the highest point and the lowest point. Imagine standing at the foot of Mount Everest. The sheer scale of the mountain rising above you is awe-inspiring. This is an example of high relative relief. Now, picture yourself in the middle of the Great Plains of North America. The land stretches out before you, seemingly endless and flat. This is low relative relief. Relative relief is not just about extremes, though. It encompasses the entire spectrum of elevation changes. Rolling hills, valleys carved by rivers, and plateaus rising above the surrounding landscape all contribute to an area's relative relief. Understanding this concept is key to comprehending the forces that have shaped our planet over millions of years. To measure relative relief, we need to determine the difference in elevation between the highest and lowest points in an area. Imagine taking a giant ruler and measuring the vertical distance from the peak of a mountain to the bottom of a nearby valley. That difference in height is the relative relief. In reality, geographers use more sophisticated tools than giant rulers. Topographic maps, with their contour lines representing elevation, provide a visual representation of relative relief. Advanced technologies like satellite imagery and LiDAR, light detection and ranging, allow for even more precise measurements. The scale at which we measure relative relief also matters. Looking at a small area, like a single mountain, will give us a different perspective than considering a larger region, like an entire mountain range. That's why it's essential to specify the scale when discussing relative relief. Relative relief is not random. The Earth's surface is constantly being reshaped by a complex interplay of geological and environmental forces. Tectonic plates collide, pushing up mountain ranges and creating dramatic changes in elevation. Erosion, the gradual wearing away of rock and soil, plays a significant role in shaping relative relief. Rivers carve deep valleys, glaciers sculpt mountains into jagged peaks, and wind erodes deserts into rolling dunes. The type of rock also influences how a landscape evolves. Climate plays a crucial role too. In wet regions, heavy rainfall can lead to rapid erosion, creating steep slopes and deep canyons. Arid climates with less rainfall often result in more gradual erosion and gentler landscapes. Understanding these processes helps us appreciate the incredible power of nature to shape our world. Relative relief is more than just a geographical measurement. It has profound implications for ecosystems, human activities, and even natural disasters. The variation in elevation creates a mosaic of habitats, influencing the distribution of plants and animals. For humans, relative relief affects everything from agriculture to urban planning. Flat, low-relief areas are ideal for farming, while steep slopes pose challenges for construction and transportation. Understanding relative relief helps us make informed decisions about land use and resource management. Even the occurrence of natural disasters is influenced by relative relief. Areas with high relief are more susceptible to landslides and earthquakes. By understanding the relationship between relative relief and natural hazards, we can better prepare for and mitigate the risks. In conclusion, relative relief is a fundamental concept for comprehending the Earth's dynamic surface and its impact on life on our planet.